Hi guys, this is Mr. Gagnon again. Let's go back to our river problem, and here's the situation that I faced. So I had a problem when I was younger. I was in the narrow river near Middlebridge. You guys probably know what that is. And the river kind of goes like this, and it actually opens up to a beach. And here is the ocean. Okay, so the ocean's here. So I was in a little tiny boat. Okay, it was a little aluminum boat with a little tiny outboard engine on the back. And we were anchored here. And we had no problem getting to this point from up here. Okay, we had the boat coming along this way. So we're fishing. Okay, we're having fun casting and catching fish. The stripers were running, and it was a good day until we realized that there was an issue. Okay, here's the issue. So the tide was going this way, out towards the ocean, and the boat was trying to go this way, back to our starting point. Now, I realized really quickly after I started the motor up to go back home that the river was stronger than the boat. The current actually was faster than the boat could go. Okay, let's put some numbers on this. So like the velocity of my boat, max velocity it wasn't much. We'll say it was about 2.5 meters per second. And in this case, I want to go back south, so I'll put a heading on it. The velocity of the river, okay, let's put a number on that. Let's say it was going 3.5 meters per second, and it was going north into the ocean. So here I am in a little 12-foot aluminum boat. I'm realizing very quickly that I'm going to be sucked out to the ocean. I'll tell you the rest of that story later. But let's get what these two add up to. Okay, so we're adding vectors. Okay, it's very simple. We're just going to list the first vector here. So the boat's trying to go 2.5. And then we're going to take and add to that from the end point. So from the head, we're going to draw another vector to represent the river. And I did dotted lines. It might be best off if you do something like a different color. But this works for our purposes. So the addition of these two vectors is in one dimension, and what I'm left with here, this little area right here, is 1. Okay, so 1 meter per second north. Okay, so I've added these vectors in one dimension, and I've got a vector resultant of 1 meter per second north. Okay, so I've added these in one dimension, and obviously that makes a problem because here I am in an aluminum boat, and I'm going to end up in the ocean. And I will tell you guys the rest of that story later. All right, so that's my simple example of vector addition. We're going to do a little more complicated one next. Okay, have a great day.